Oh, we're live. Okay, yeah. It's January 26, 2014, 11 o'clock in the morning Pacific time. And this is DB Hangops. I'm Jeff. I'm the DBA at Box. And if you guys want, let's do a quick round of introductions. You can go first, Jerry.
Hi, I'm Jerry Narvaja. I'm the co-host of the Our SQL podcast and sales engineer at SkySQL.
Okay, Mark.
Hey, I'm Mark Leith. I'm a software development manager at Oracle.
Okay, Morgan.
Morgan Tucker, MySQL community manager at Oracle.
And Tim.
And I'm Tim Callahan from Tokutech.
Okay, cool. So today, the Oracle. So today, sorry, there is a chat window on the side that people are already starting to put some stuff in. But so the topics for today are semi-sync replication, and I think Morgan has a pretty snazzy demo put together. And then Mark's going to be talking about performance schema. And I think as we're doing this, I mean, I'll leave it up to you guys that are presenting to dictate direction, but I feel like fielding questions and asking them as we go along is probably the best way to keep this going. So if you want to take it away, Morgan, go for it.
Sure. Just as a follow-up to a conversation, I think a bit over a month ago, we're talking about semi-sync and who's tried it and does it add latency and is it going to be problematic. I wrote a blog post and said that it's obviously going to be slower than async replication, which is the default. But it gives you an alternative to having local durability, and that you can have durability over the network. So particularly in cloud environments, where if you use Amazon or if you use DigitalOcean or Rackspace, they'll offer you an option where you can spin up servers that have physical isolation but are close by. So Amazon, for example, calls these availability zones. And the latency here is actually pretty good and kind of comparable to what disk operations cost anyway. So semi-sync was introduced as a plugin in MySQL 5.5. It works. It's okay. It has a lot of enhancements, though, coming in MySQL 5.7, and the performance is pretty good. In my blog post that I wrote, I showed that it can be much better performance-wise to use semi-sync than to use local durability, where you have, InnoDB in the binary log safely make sure that its changes are saved. They're not quite directly comparable because we don't quite have all of the same tools with using network-based semi-sync to be able to do crash recovery. But today, what I might demonstrate is really just the installation process of semi-sync, and then maybe we can try some failure scenarios to describe what would happen. So I have set up a basic MySQL installation on 2 DigitalOcean instances using asynchronous replication. And I'm going to figure out how to share my screen. And then I'm going to convert it to using semi-sync. So here we go. So I'll wait a couple of seconds to make sure that my screen share shows up.
Looks like it's there for me.
Looks like it's there. So in the top, I have my master status. And the bottom here, I have my slave. Show slave status. Wonder if I make that bigger, does the feed resize, or does the
It disappeared.
Looks like you turned off your screen share.
Oh no! Hold on a second. I'll turn it back on. Okay.
Morgan, while you're working through that, I'll ask the stupid question. Can you give a very short definition of what semi-sync replication actually is?
Oh, sure. Great question. So in 5.5, what semi-sync meant was that when a client commits a transaction, the master would commit locally, it would block, and it would try and send that across the network to a slave and make sure that the slave had received that change. In a failure state, it was actually possible that the master could have the transaction committed. The client doesn't know about the transaction committed, and the slave never received it. So in 5.7, though, what semi-sync means by default, and it's actually configurable to have the old behavior, is you can have lossless semi-sync, where the master will make sure that the slave has received the change before the master will commit the change itself and give that acknowledgement back to the client.
This is Jerry, and just to clarify, this is true with transactional storage engines. So this still wouldn't work that well with MariaDB because there's no sense of transactions, right? With MariaDB, no, I'm sorry, with MyISAM. Sorry about that.
Sure.
Nope. Edit that out.
With my ISAM, I'll be truthful, I haven't tested it. But I'm assuming because in everything else in MySQL, it kind of implies like an auto commit. When it writes it locally, it's written it locally, and it can't pause and hold that off, waiting for it to be received remotely before it can then commit it locally. So I assume that it's just the same with replication behavior, where you just can't roll anything back.
And then my question to Tim is, have you tried any of this with TokuDB?
I have not personally, no.
Are you aware of anyone trying it?
Not that I know of, although it sounds a lot more interesting in the MySQL 5.7 implementation.
Yeah, I think that's the trick to it. It is a lot better in 5.7, and I don't know of too many people using 5.7 yet.
Not yet.
So let me just show my replication. I have a database called AA, and I have a database on the slave called AA. Let's create a database, and let's call it BB. Show database. And we can see that we have a current replication stream working. So now what I'm going to do is I'm going to change my asynchronous replication to be synchronous. And I'm just going to follow the steps that I outlined in this manual page, and I'm going to paste that into the chat. So what it says is that on the master, I need to install a plugin, the semi-sync master, and I just run this command to be able to do that. And on the slave, I have to install a different plugin to be able to be a semi-sync slave. And let's install that plugin here. Once that's done, on the master, I have to say that I want to enable semi-sync. So I'll say yes, let's enable that. And I can say what the timeout is for semi-sync. What this means is that after this timeout has been reached, the master will not block clients waiting for that slave to acknowledge that change. It'll just accept them. So the default is going to be 10 seconds, and it's specified in milliseconds. Let's make that 10 seconds as well, just to show that that configuration setting is possible. And then on the slave, I need to say that I want to enable semi-sync as well. That change has been enabled on the slave. The only other change that I have to make is the slave has to stop and restart its I/O thread. So stop slave I/O thread, start slave I/O thread. And then I have semi-sync enabled. So being familiar with MySQL, you'll know that those changes actually won't persist. You will have to set them in your configuration file as well. The options are, as I described, and in the manual, I'll just paste into the chat what it suggests that you might want to set. So set that on the master, and set on each slave.
So I have a
That's a
quick
good
question
setting.
about
Sure.
this, Morgan. So now that you've now that you've restarted the IO thread on your slave database, is there a way that you can actually confirm that semisync is running? Is there something that comes up in show slave status that would indicate that?
That is a good question. And let's check if show slave status says anything about it.
There's nothing in show slave status for it because a plugin can't extend that command, but there are status variables in show global status which tell you the amount of transactions that have been done with semisync, the amount of transactions that have fallen back to having no semisync because of timing out, and those kind of things. There's a few of them on there.
Replication semi-sync slave status on.
You want to look on the master. The master has the most statistics about it, not the slave.
Okay.
Wow, there's a lot of stuff there.
So I haven't actually tried sending any statements yet. Let's try making some changes. So my latency, let's just check it. Okay. This is the IP address of my slave. Let's try and ping it. So we're about half a millisecond for latency. I tested the disk I/O previously on this machine.
We lost your screen share, Morgan.
Thank you. It still shows up as shared on my screen, but let me start again. Is that working now?
Yeah, shows again. Thank you.
No, thank you for the notification. So I have about half a millisecond latency for network round trip, and I have about 0.8 milliseconds for disk I/O. So I'm actually faster in network latency than I am in disk latency here. It might not be the best example because I have these two machines set up in the same region with DigitalOcean. But what I want to show is just if I start a simple transaction. Actually, let me create a table first. So use pd, create table, my table. When I say this is when these changes are going to be sent to the slave. And then if I use here, show tables, see that the rows have been received. So my thoughts here is that I might be able to show a failure scenario where I kill -9 MySQL running on my slave while I have a transaction started on the master, and then I try and commit it, and we see that that master block waiting on that timeout. We can try other failure scenarios as well, and maybe I can answer questions. But that was my thoughts. Anyone thinking otherwise?
I would love to see that personally.
Okay, excellent. So PS, let's kill hard kill, and I'll view that up. MySQL D safe and MySQL. And now let's start a transaction. So I've got my first change made, my second change made. Let's kill the slave. Try another change. Try another change. Another change. And now I'm going to try and commit. So I set that timeout to 10 seconds. After 10 seconds, what's going to happen is that transaction is going to commit. So if you have multiple slaves as well, what semisync in 5.5 offered was that it would wait for one slave, non-configurable, and one slave had to acknowledge that that commit before the client was able to proceed. With 5.7, I forget what the option's called, but I believe we've introduced the option to be able to specify the number of slaves that you will wait for, or you will wait for that timeout period instead. But it's mostly, it's very transparent to apps. If you have a low latency network, if we look at something like the InnoDB storage engine, it does a lot of I/O locally to be able to offer things like the double write buffer. And you probably have a failure, I've heard about 10% of the time, where InnoDB can't restore because it has a torn page. And if you chose to run without the double write buffer and use semisync instead to be able to provide durability, in that 10% scenario where you have a complete failure, well, you have the data from your semisync slave instead. So that's the end of my demo. Any questions or other tests that you would like me to try?
This works the same whether you're using, right now you're using traditional replication, but if you were using GTIDs, it doesn't matter. It works exactly the same, right?
That's right. I can't think of any differences. In this demo, I am using regular replication. I set up the dumbest example where both machines started with no data. I set a server ID, and I turned binary logging on the master.
And it doesn't discriminate between statement or row-based replication. Both will work as well, I assume?
Yeah, I can't think of any limitations there.
I feel like I have another question. I just can't think of it.
Yeah, it's fairly simple to be truthful. The big performance enhancement that came in 5.7 that was most visible was when you're parallel inserting, it manages to sort of, I guess group commit, is that maybe the right word, but it manages to be a lot more efficient in that scenario.
Something I'd be very interested to know about this, and just maybe on a larger scale when it's operating, is how this looks with large transactions or transactions that run for a long duration of time. So a problem that we see in our environment sometimes is a transaction that'll run more than a couple seconds, maybe upwards of a minute or a couple minutes, right? And when that commits currently, the slave will get it, read the timestamp, and show slave status will show that it's actually a minute behind when it gets to that first statement, or however long until the commit would have happened from the original statement. So with something like this, I'd be curious how show slave status looks over time, like if it's always actually caught up. But again, the downside to something like this that I can see is you create a very, very strong dependency between two separate physical servers, and a master and a slave in this case. And if the slave starts to have problems, with its hardware and stuff, you're going to start blocking until that timeout on the master.
Right. In theory, you have lots of slaves, and you're just waiting for one to acknowledge. So if you had the simple setup that I have, certainly that slave failing would cause you that problem. But if you had a few slaves, hopefully you can avoid that.
Do you have a question, Jerry?
Yeah, I feel like I cut you off, Jerry. Sorry about
that. No, I was going to comment on that, but Morgan addressed my comment. So.
Okay. Has anyone else used semisync replication in a partially or semi-production environment, or actually full out in production anywhere?
I don't know too many customers using it, which somewhat surprises me, but then I think what's been blocking them is those changes coming in 5.7.
Okay.
Every time I talk to someone who tried to use it, network latency were killing them in performance. So this might help.
Gotcha. So actually, Morgan, or maybe anyone who's familiar with the feature, how has this changed over the past two versions of MySQL from 5.5 to 5.6 to 5.7? Because you had said 5.7 brings in a large number of performance improvements.
Yeah, so I can't think of any changes between 5.5 and 5.6, unless Mark can correct me. Between 5.6 and
There may have
5.7.
been a few little bug fixes or something like that. No, I mean, I don't think there was much changed in 5.6 at all for semi-sync. Very little. I mean, bug fix type things, I think.
Yeah, for 5.7, the main changes are that in parallel, it scales very well. And it has that lossless semi-sync where it will wait until a slave has received the transaction before it will commit it locally. That's code that I think was handed to or suggested by Facebook, where they describe the situation, and it's true, where it's kind of like a phantom row where something could be inserted on the master and then lost.
Actually, that brings up another good question, and this might be a little outside the scope of this example, but how does it look if you have a different isolation level set between a master and a slave, and you're using semi-sync? Does that actually cause any sort of concerns or data integrity issues between them?
I probably have to think of that question more, but it's not much different than regular replication. And actually, the question you asked before with the timestamps being behind on the slave, that would still be the case because those timestamps are from the context of those statements running. It's a little bit of metadata that's used on the wire to serialize to seed temporal values. I can't think of any differences from regular replication there. All of this is a guarantee that one or more slaves has received a statement.
Okay, cool. Does anyone else have questions or things they'd like to see about semi-sync? Tim? Okay. Anything else from you, Morgan, or should we move on to what Mark has to talk about with performance schema?
Nothing more from me. I think this was just a little introduction to show that it's a pretty good retrofit and it's fairly easy to set up. And I hope more of us will use it in the future. Some of the roadblockers have been addressed very well.
Okay, cool. Well, thanks very much for getting the demo put together today, Morgan, and showing it off and fielding our questions. So now, I guess without further ado, Mark, coming over to you, talk about some performance schema.
Okay, let's see if I can actually figure out how to share my screen then.
I feel like I should make a training video for how to use Google Hangouts.
Yeah, tell me about it.
Well, they keep changing the behavior somewhat. All the little banners, with the names and all that, they're not showing properly on my browser today.
Like the bottom third?
Yeah, the bottom third.
Section?
Yeah, I'm not seeing the icons.
Off topic, but I have to figure out how to get one of those little banners as well. So if you make a tutorial, I'll certainly watch it.
Oh, it turns out it was the width of the browser window.
Does it like clip it off if your browser's too narrow?
Yeah, but narrow being a very relative term because it wasn't narrow.
So I'm supposed to hit this screen share button, right? That's on
Yep. So you hit screen share. It'll pop up a dialog asking which window you want to share.
It hasn't popped up anything whatsoever.
Is it hidden somewhere
It's
on your desktop? It might. Whoop. It looked like it might have been loading for a second, Mark, and then you turned it off.
no. It's literally just not doing anything.
I think you just lost Mark's audio.
Hang on. Yeah, I've finally found
If you tab out, it loses the memory of which screen it's supposed to share.
Am I actually here, or? Hang
Oh
on.
wow, Mark just got intense latency.
I'm just going to share my my whole desktop, and we'll get some recursion going.
Hey!
Oh man, this is just Inception right now.
Can you see my?
Guys.
Can you see that?
Hey.
At least.
Yeah.
How's that?
That's good. You got it.
So that's good. Okay. So kind of like Morgan, I've got a 5.7 master and I've got a 5.7 slave. They're actually getting activity and things like that from a mem instance or enterprise monitor instance that I've got running on top of it. So I'm just going to talk about the 5.7 stuff. I mean, you guys, before we even start, have you guys got any questions about performance schema up to 5.7 before I kick off? I mean, people have actually started looking at it and using it and those kind of things. And we talked about it a long time ago, but I wondered if anybody's had questions since that time.
I think the only question I have, Mark, is have you created an updated version of PS Helper that works with it?
Yeah, so the sys, the project on GitHub itself, under my name on GitHub, same place as PS Helper. And the idea with sys is to make it a more generic thing, so something that can be or give overviews of not just performance schema data, but other kinds of things as well. So this is sys, if I can write it properly. And it's basically like PS Helper was, but it's got a bunch of $$ views, which are the raw output of the views rather than formatted views, and then a bunch of formatted views on top. A lot of it is performance schema data, but there are things that are in there which, like the InnoDB buffer stats, for example, which come from things like information schema. It works with 5.7 and 5.6. And the idea with that is to try and get it, hopefully, in as close to the server as possible, maybe even in the server in 5.7 as well. Sys has actually started shipping with Workbench as well. Workbench actually takes this whole schema and gives the user a really easy way to just load the schema into their database, and then exposes a bunch of views. It exposes views into this data from Workbench itself, so you can pull up the reports from there easily. So.
Oh, I wasn't on mute. I'm going to paste something in the chat, which is an example of Workbench's performance schema reports. They call them performance reports, and it installs sys to be able to aggregate some data in it. It's pretty nice.
Okay. Yeah, I'll show some of the sys stuff in a little bit as well. So in 5.6 there were all of these kind of tables, the stages and the statements. People should be getting familiar with those kind of things now. The states that connections go through when they're executing things. the actual statements that they're executing. In 5.7, we've added all of these as well, which are the transaction details. So just to show you what that, show you what that looks like. Details of a transaction itself. So the thread, who executed it, where it executed, what kind of transaction it was, the transaction state as well, because this is current. This could be, currently executing transactions. It can tell you what state the transaction's in at the moment. The IDs and the GTIDs and XIDs and the like of the transaction, and then the timing of the transaction on the whole. And how the transaction was executed. So, whether it was a read-only or a read-write, there's been a bunch of optimizations in ODB in 5.7 for read-only and read-write transactions, for example. What isolation level it was, or to commit, whether it used save points and those kind of things, and then the nesting type info that is there with throughout the rest of the stack of performance schema as well. So you can nest or find out the statements that nested within the transaction, for example. Let's see if I've actually got some in a history to show as an example. So yeah, so you can see, you get the thread ID and the events and the like, and the actual transaction statistics. GTID is it's set to automatic there. I don't know why. I haven't figured that out yet. That's one of the questions that I need to figure out. Then the timing info in picoseconds, so you might want to format those kind of things, and how it actually executed. And this is the history long table. So unlike the current one will show you the currently executing or last executed transaction for each thread. The history long will show you the last 10,000 transactions by default, and the history one, like the rest of the tables, will show you the last 10 transactions per thread that are connected as well. And then you get the normal summaries of transactions too. Show the global one. The summary itself isn't so much these individual statistics. It's actually the count of transactions overall and their timing overall, and then breaking out the transactions by both read-write and read-only transaction timing statistics too. And those are either at the global layer or like with other things, you can see it by thread ID or by user and those kind of things as well. And then moving down the list, these were all there in 5.6 and 5.5. And we've added all of these in 5.7. This is one of probably the biggest project that was there in 5.7, which is basically instrumenting memory within the server as well. So where memory is being what we do is we track the memory allocations themselves. We don't track any of the timing stats for memory in performance schema. The overhead for timing all of that stuff would just be too much for it. There's a lot of memory allocations that happen in the server. So what we do instead is we just do some accounting of the memory itself. So we break it down by the different types of memory. Show a snapshot. We break it down by the different types, so you can see this is performance schema, internal buffers, transaction spaces for the thread. Other things, they all take some kind of memory in the server. So we track how many times they've been allocated, how many times they've been freed, so that we can see differences there. The total number of bytes that were allocated and freed, and then we track both the low water and high water marks of those things as well. along with the current counts of those things. So you can get a better view into, really where the memory is being spent. A lot of this might be a little hard to get your head around if you don't know some of the internals of the server, for example. But these are stored procedure memory caches and things like that, for example. So it's going to take a little bit of getting used to what these things are, and indeed some buffers are just generally named as well. For example, you'll see things like try and find ones with MySQL.
I think that's
Type of
true, Mark,
memory
but
allocation
you
in
can
the
also
server.
view it.
Here's file sorts, for example, and you can get a pretty
You can
decent
view it in
overview from that.
aggregate.
To show, you can, right? So there's this. I've already added or started adding things on top of these views in performance schema in sys, because it's just hard to read, these big long numbers to see what they are. And some of them will be aggregated as well. So I do it by user and by global allocations and the like. So it breaks down the output instead of having these big outputs out with overall current allocations, and it's sorted by the currently allocated. So the highest is at the top. The one thing to point out here is InnoDB isn't instrumented for the memory accounting in 574. The work is being done right now for it, so I mean it's coming pretty soon, hopefully. But this doesn't have any memory accounting, which in at least our database server under mem were heavily InnoDB. And it would be, it takes most of the memory, but it's not accounted for here. So that's one thing to be aware of on 574 at least, but it will be coming along pretty soon. But yeah, you can.
Mark, can I get a question in, Mark?
You can see have been allocated. If it's always the max, then you want to increase it. Yeah. Sure.
Mark, I have a question that kind of follows up on what Jeff typed into the chat.
Go for it, Tim.
Mine's a little more general. There's always the challenge. I know performance schema has overhead. So there's the overhead of tracking information to try to help you have insight on performance, but the overhead is affecting performance, right? So it's kind of the challenge of capturing data that's actionable without hurting your server to the point where you can't afford to let it capture the data. So how, I've blogged plenty of blog posts talking about the overhead in the various MySQL releases. Strategically, how can that be kept under control? It seems like it's very fine-grained, and you can enable it and disable it where you want. But how do you produce these kind of metrics in a way that the world is willing to actually run them in production, so they can get value out of the work you did to instrument them in the first place?
Yeah, I think there's different modes that you actually want to use them, right? I mean, there's always different modes of software development itself, right? So for instance, if you're debugging a problem with some application, with the database server, whatever it might be, you turn on some debug level logging and record the hell out of everything, right? And that's really the case with some of this instrumentation as well. Things like mutexes and read-write locks and the like. That's, those are, for the most part, developer level debug type tracing, for example. So my advice, at least, is on any production system, adding the instrumentation for things like the weight sync classes in performance schema just isn't worth it. because you don't get much benefit from it, right? You might see that the buffer pool is hot or the query cache is hot or something like that. And in that case, you can just enable those couple of things if you're interested for a while. Otherwise, turn it all off, right? Don't enable everything. Then there's things like development itself, where you don't want a debug log, but you want something more like a message log, right? You want to record a little bit more about things. And in that case, then you can start turning on things like the histories, so seeing the longer histories of statements and the like. But not have those things on in production, in production systems. In which we think has a fairly decent overhead, right? I mean, in most benchmarks that we've seen recently on these versions, Dimitri does a bunch of benchmarks and I like as well. For the default configuration that we give, which is it gives you statements, so a bunch of statement instrumentation. The memory stuff in 5.7 is turned off by default. It gives you file I/O and table I/O, for example, and user statistics as well in some cases. And the benchmarks show about 5% to sometimes 6-7% on some workloads. There's stuff that we're doing in 5.7 to hopefully tune that even further with things like table I/O and batching table I/O and the like. So we're at least very aware of all of the performance overhead things out there that people talk about, and we're trying to fix them. There are some things that aren't as efficient as they should be, but we've tried to be as efficient as possible with a lot of this stuff in the design of it. So it's really, I think, a case of finding what is the best configuration for the right amount of data that suits you, in the environment that you're in as well, right? You probably only want to track summary data over time in a production system and not enable histories unless you're trying to debug something on it. And use the histories and a little bit more instrumentation in development, and then if you're really trying to debug something, turn everything on.
Yeah, Mark, from my perspective, what I see here is
that's actually one of the beauties of performance schema as well, really.
I feel like there's about a 5 to 10 second latency.
Go for it.
But yeah, I feel that something that might actually be super beneficial here is pretty much what you said, which is running this in a development environment, perhaps. If you find a problematic query in production, and you want to try and get more information to see where the time is actually being spent on that, so you can maybe get some more information about how to properly tune it, or maybe variables that you want to change, or see if a new config option that you're flipping on in the server is causing some extra time to be spent somewhere. Like, I can see that it would be super valuable here. And so you had mentioned summary and kind of the aggregate and history tables, because the other thing I was wondering was, would it be valuable to turn this on maybe for a second or two, a couple times an hour on a production server instead of having it on all the time, to get some semblance of memory performance information that you could kind of plot over time? And I guess just what's your take on that, and then, yeah.
Yeah, I mean, I guess it really depends on the overhead for your system turning it on first and foremost, right? I mean, if it doesn't affect your overhead too much and you're happy with it, then just leave it on because it could help you. That being said,
yeah, I have a comment on that one as well.
I'll go for it.
I think one thing that I've always found curious is when people will disable logging, they'll have no visibility into their system, they'll have very good performance, and then they have higher throughput, so now they have performance problems, and then they have to turn on logging to be able to get diagnostics, and now they have even worse performance problems. So performance schema it's designed in its default configuration that it should just always be on for production. And as Mark said, our goal is somewhere around the 5% or less overhead in that default configuration, with you having the option to enable extra things on top of that if you need more visibility. If I were to sample, what I might do is I might pick a couple of database servers in a pool of servers and leave performance schema on those and off on others, or instrumented to further detail on those and just on the default configuration on others. I think that might be the better choice.
Yeah, and people, I know people that do that, especially in larger environments, right? Because one of the other things that is the problem is you want to track these stats over time, right? Or you want to get some semblance of some of these statistics over time. But when you've got a huge pool of systems that you're trying to do this, it turns into a huge amount of data as well. It's not like the status counters; it's status counters times n, right? Where n
Right.
is quite a big number. So. Yeah, I mean, what we've seen people do is pick pools or pick, one or two slaves out of a pool or a shard or whatever it might be in the larger sites and just use those for statistics gathering. They still, get roughly the same load as the rest of the systems. So they're a good enough indicator of what these kind of statistics could be. At least with things like the query analyzer data that we use and that is starting to come from PS out there in all this other tooling as well. That's a lot of data that can come across, and it's just the same with all of these kind of things too.
I do have one more question, if you don't mind my following up. I know we have a latency issue. So with TokuDB, we capture a lot of statistics and metrics. We don't currently publish anything to performance schema. What I'm wondering about is, this measurement of overhead, and I've seen some people complain about it. It seems like there's been some improvements over time. Is the true overhead the actual capturing of this data into performance schema and holding on to it and retaining historical data? Because the metrics themselves within TokuDB, we don't enable and disable them. We're always capturing the metrics. And what I'm wondering is, in InnoDB or other MySQL internals, are you actually stopping even the capture of the metric, or is it just a matter of publishing it to performance schema and having it held onto for historical reasons?
That's a great question. I'll let Mark answer it first.
So there's a couple of bits of overhead. Yeah. There are a couple of bits of overhead. There's the overhead of actually recording or doing something with the instrumentation, whatever it might be, right? Because depending on the type of instrument, you record different things. Mm-hmm. So there's the overhead of that and timing on top as well. If an instrument is timed, because you can do timing or not, and timing gives a little bit of overhead. And then there's the overhead of the consumers themselves. So that's why there's a couple of things. There's what's called setup instruments and setup consumers. The consumers are the things that pull the data into these histories, right? So I've actually got everything enabled. I use this as my dev machine underneath that mem instance, so I track everything. But the more that you turn on with these kind of things, with the history and the history long, the more overhead there is, because you're actually getting the weight data getting copied into these buffers, which are essentially ring buffers in memory for the histories. And the more that happens, the more the overhead is. So for instance, if you turn on something like all of the events, weights, current, history, and long, and you turn on all of the mutexes and conditions and read-write locks that happen in the server, then it's going to try and record those histories across all of those couple of tables millions of times a second, on top of actually recording the statement summary table. or the event summary data itself. So there's layers that really build up in terms of overhead, and it really does depend on what's pulling in the data as well as how much you're actually recording. I hope that answered the question. But
yeah, if I can expand on Tim's question, sometimes when overhead is always there and it just becomes budgeted, you don't consider the cost of turning that off because there's no option to disable that. But I know, at least in the case of the InnoDB team, the command show engine InnoDB mutex, it had some cost accounting that was happening all the time, whether or not you use that command or not. And that command has become obsolete and removed in 5.7 in favor of just using performance schema statistics to provide the same information. And I think overhead's being reduced as a result of you now having the choice of disabling that. But previously it was always on, and so it was always accounted.
Okay. Yeah, the reason for my question was, we have a metric, the number of CPU seconds that we've spent compressing data on its way to disk, and we always know that number. You don't turn that on and off, and based on and off, we keep track of the number. But at some point, when we start pushing to performance schema, we'll still be always tracking that. And it sounds to me like the overhead is whether or not I'm going to push it to performance schema, which costs me something, or if there's a consumer over there that's grabbing it from me, which will be additional overhead for TokuDB when we start participating in performance schema.
yeah, the thing with performance schema is it actually it's not, well, there isn't something there for random statistics at the moment, right? So something like CPU seconds compressing something isn't something that you could push there just yet. It's a status variable, and we are trying to get status variables into 5.7 as well with performance schema. It's something that's not there at the moment, but it's an improvement on status variables in PS, where session variables are only shown to, if you look at session variables, it only shows session variables, and you can look at them across different threads and things like that as well. So you can see session X's variables, for example. For other things with performance schema, from a storage engine perspective, you pretty much deal with the API, right? So it exposes something that's wraps things like mutexes and file I/O and conditions and read-write locks and all the things that are exposed at the moment, and instead you use those APIs in your storage engine, and that's what does the recording of the data for you. You just register them in performance schema, and then you use the wrapped APIs. And it gives you the things like file I/O and all of those kind of things essentially for free. It pushes it into PS for you.
Can we
it's
not
worth experimenting with? I'd say that at least.
Can we not extend the performance schema?
You can, but you'd be extending performance schema, right? Performance schema is a storage engine on its own and a bunch of interfaces in the server. Essentially, that's all it is. So I mean, you could extend it if you wanted to. It's a storage engine like everything else. Or you can ask us to put different things in that help you as well, I guess. Just log a bug in bugs.mysql.com or a feature request or something like that if there's something missing. I haven't got long, so I want to show a couple of other things. Just quickly, we do actually track metadata locks in the server now as well. You can see them no matter what the scope, so it could be a global flush tables with read lock, and we track all of those kind of things. Or down to a specific table lock, a specific lock type, and you can see the owner of the metadata lock, so you can trace it back to sessions and all of those kind of things as well now. So no more of the mysterious metadata locking problems. It's all pretty transparent with that table there now. One of the other things, I mean, I'd been playing around with all of this data. It's much a single SQL statement. So just to show it real quick, this big, long, hairy SQL statement that's hidden performance schema. And it goes and gets all of the data from a bunch of the history tables. This is a development mode SQL type thing, right? A debug trace. Let's put it that way. So you can see the user, the thread, all of its last transactions with the timing and what state it was and some of that high level info. And then within the transactions, if there is the history there, because the history ages out, you see, so these don't have any tracking of statements. But here you do see that this is a statement. It was a commit. He's just doing empty committed transactions here, so that's a bit wasteful. But you also see what metadata locks the thread has, and this is just a single connection and the data that we can get, whether he's got any open table handles, the memory summary, so how much memory this connection is actually got in total and where he's spending his memory, the top stages for the connection, so where does he spend most of his time, what's he doing, and the wait summaries. So you can see in this case I've just got normal table I/O happening and table locks, not really much happening on this one. Let's see if I can find something a bit more interesting. Well, no, it takes too much time. But you can see it prints out one of these for each connection. And looking at the data in this way, for me, it's found a bunch of bugs in mem. I mean, we were using this with mem, and it found, for example, we had a metadata lock list which was longer than the screen, right? And it had gone through. We found a transaction that was going and deleting in loops of like 10,000 rows, but was supposed to be committing every 10,000 rows, and the commit was lost, so it was looping through the entire database and doing this huge delete and holding on all of the metadata locks across all of those tables while it was doing it. Then missed the commit at the end of the transaction and was waiting for the next connection to pick it up from the connection pool to auto-commit that old transaction that was holding open all the deletes. We didn't see that until we saw this with a huge list of metadata locks and a transaction that had all of those delete statements nested within it when I was looking at it like this. Looking at the data in that kind of way in a development system, understanding the transactions and their timing and what each of those statements are actually doing within those transactions as well, and how long those kind of things take, brings a lot of benefit. I've got it's just like this random great big long thing, right? But there's a lot of great data in there in 5.7. One of the other things, this is the slave. There's awesome. A bunch of replication. There's a bunch of replication info in there as well now. So actually, I'll show them. It's these. So we've broken down the replication show slave status for the most part into a properly broken out set of data. So there's the connection info, which is who this slave is connected to, and then there's the execute configuration for the SQL thread itself, and the status of those things as well. These are really high-level things. So to show an example.
I think you might be about to get cut off, Mark. The time.
Yeah, I was about to say we're
So it
hitting
just
12
shows
o'clock.
you the state. I'm actually
What I was
using
going to say about your
threaded
JSON statement.
slave on this system. Ah, okay.
Your
Um,
JSON statement looks
so
really good
yeah,
for
I
CI
mean,
environments.
go for it.
Sorry, I was just going to say that big statement you had. I would love to.
Yeah, I
Every
mean,
continuous integration
it's
in the world.
how I want to interact with some of this data, right? I mean, I and pull it and yeah. I mean, it's the way I think about it, right? When I'm testing this stuff, we with MEM we have to test, pretty rigorously, and that's how I think about pulling some of this data.
Okay, I think I'm
And
going to
then
jump in here and cut us
I just
because
want to
we
end.
are out of time. And it looks like Morgan left on that 10-second asynchronous semi-sync thing, so Mark is just hanging off on the end, getting cut off right at that 10-second latency thing. But this was amazing stuff that you showed, Mark. And like Morgan said, I would love to see that query that you have that was grabbing all that stuff, generating that beautiful JSON. That looks like it would be great just to run in a dev environment for being able to get access to full-on statistics around queries and transactions that are being executed from an application to figure out where the bottlenecks are and ways to improve them overall. But yeah, that aside, so we actually are over time. So I think I'll take real quick, maybe like 30 seconds for topic solicitation, and then we can go ahead and just wrap it up for today.
No
I got
ideas.
nothing.
All right. Well, I guess I'll work with people and maybe last minute pop some things on Mark or Morgan again to do some cool stuff. If you have anything that you're interested in talking about, if you're even just watching this, separately, feel free to contact me through email or Twitter. We always love to have new topics come on here, new people talk about things, especially demos. And beyond that, thanks very much for your time today, guys, and we will see you in 2 weeks.
Thank you. It's been fun.
Okay, cheers, guys.
See you, everyone.